All right, let's go ahead and talk about page 6. So before we start into these problems with Pythagorean theorem, right, you notice that they have radicals or they have square roots. I want to go back and look at this, right? When we have a radical, so let's say we have radical x, and we went ahead and squared it. We saw what happens is that they basically cancel each other out, and what pops out is the original thing, right? So if I'm looking at this one, I have the square root of 10 squared. That means I have to rewrite the square root of 10 2 times, and I multiply it together. If I did that, I have the square root of 10 times square root of 10. I'm going to multiply 10 times 10, which is 100. And if I take the square root of 100, that gives me 10. So what happens is that if I start with 10, right, I'm going to end with 10. So same thing over here. I have the square root of 12 squared, so that means I'm going to rewrite the square root of 12 times square root of 12. 12 times 12 is 144. If I take the square root of 144, what pops out is just 12. So again, I start with 12. I'm going to end with 12. Okay, so let's go ahead and take a look. Examples 1 through 4. It says find the missing side of each triangle. Leave your final answer as a radical. Okay, so here we're going to go ahead and use our friendly Pythagorean theorem, which we know is now a squared plus b squared. So I could say a squared plus b squared is equal to c squared. And this is what we want to use. So if I'm looking at number 1, I'm looking at my triangle, right? We already have b across from my right angle is c, and here's a. So if I wrote a squared plus b squared is equal to c squared, my a is 5 squared, so I'm going to say the square root of 5 squared plus b squared is equal to c squared, which is c is the square root of 14 squared. Right, so if I were to go ahead and pull up my calculator, let's see, it was glitching with me earlier, but if I take the square root of 5 and I square it, it gives me 5. So this becomes 5 plus b squared is equal to, same exact thing, if I go ahead and plug in 14, it's going to give me 14. And I keep on solving. Okay, I'm going to go and subtract 5 on both sides. And with b squared is equal to 14 minus 5. Is that 9? Okay, and then I take the square root of both sides because I have to find one b, so I get b is equal to, we know that the square root of 9 is 3. So this guy is 3. Okay, so let's go ahead and look at number 2. Same exact thing. If I'm looking at my triangle across from my right angle C, we're trying to look for b, so I'm finding, so I got a, right? When I rewrite my equation, a squared plus b squared is equal to c squared. A in this case is radical 10, so I have radical 10 squared plus b squared. We don't know what b is just yet. C is again radical 14 squared. And I'm going to go ahead and solve. Same exact thing. If I take radical 10 and square it, I just get 10. Plus b squared is equal to, if I take radical 14 squared, it's going to give me 14. Let's keep on going. I'm going to go and subtract 10 on both sides. I get b squared is equal to 14 minus 10 is 4. And same exact thing, like always, I have to take the square root on both sides. So the square root of 4 gives me a value of 2. Okay, let's go on to example 3. Same exact thing. I'm going to rewrite my equation. I have a squared plus b squared is equal to c squared. If I'm looking at my triangle, right, I have my c. I need a and b. Okay, so I'm going to go and plug in. I have the square root of 46 as my a, so I have the square root of 46 squared plus my b is a radical 11, so I have radical 11 squared is equal to c squared. Right, you might already be catching on, but I could go and plug in my calculator. 46 squared gives me a 46 plus 11 squared gives me 11 is equal to c squared. 46 plus 11 gives me a value of 57 is equal to c squared. And I'm just going to go and take the square root of 57 on both sides. So I'm going to go and take the square root of that. I get c is equal to, so this one is not a nice number. I can leave it as the square root of 57. Or I can put it in decimal form, and let's say that we're rounding to the nearest 10th place. So one place after my decimal, 0.5, right? The 4 does not round up the 5, so it's just left at 7.5. Okay. All right, let's try the last one. Let's try example 4. Okay, so if I'm looking at my triangle, across my right angle is my C, I'm left with A and B. I have A squared plus B squared is equal to C squared. A is 5, so I have 5 squared plus B squared, which is the square root of 17 squared, is equal to C squared. And this time around, right, the 5 is not underneath a radical, so I have to go ahead and do 5 squared. 5 squared is 25, so this gives me 25 plus, I have the square root of 17 squared. That gives me 17 is equal to c squared. I can go ahead and add 25 plus 17. That gives me 42 is equal to c squared. Right, trying to get one c, so I have to take the square root of both sides. If I take the square root of 42, it is not a nice number. It gives me a decimal, so I can leave my answer as a square root of 42, or I can round to the nearest tenths place. So this one is 6.48, right? The 8 is bigger than 5, so I do have to round up the 4. So it would be 6.5. Okay. And I think that's it for today.